Here we go. All right, so the purpose of this video is to show you an example of thin film interference, and maybe it looks pretty cool, and it can also get used to, I can help you understand where these reflections come from. So first off, let me show you what the apparatus is. First, the key is to have one Angus, that's critical. We have a large, a very bright light source, and we want to have a very diffuse light shining on the bubble. Can you just pull up the bubble real quick? So the idea is what we're going to do is, instead of shining this bright light directly at the bubble, which then gives a really bright reflection for just one student in the class, what we're going to do is we're going to take this large, basically white poster board and put it in front of here. Make sure that's approximately right. Is that good? Yeah. And this is nice for a couple of reasons. It's going to block the direct light into the bulb, and then we're going to see the light bounce off this white surface. It'll be very large, diffuse white light source, and then we'll see it reflect off the bubble. Now, there's going to be a reflection off the front surface of the bubble at the first water. Oh, go ahead, bring up another bubble. I'll hit the lights in just a second. So we're going to have a reflection off the front surface, the first interface of the water or soapy water air interface, and then there's another one back here where there's going to be a second interface. And the idea is thin film interference is the reflection from the front and the reflection from the back interfering. Let's hit the lights so you can see this better. Okay, go for it. Oh, and I'm going to zoom in as well so you can see it a little bit better. Let's keep zooming in. Oops. I'm going to go down just a little bit here. All right, so you can just barely see that light source in the corner. Let's see if I can get rid of that. Zoom in just a little more on the bubble. Oops. I'm going to go up just a hair. Sorry about the slowness here of my controls. All right, and so now we're seeing the soap bubble illuminated with red light, only red light. And notice you'll see, go ahead and get us another bubble. I'll hit this light so we don't see that. All right. Now it takes a second for the pattern to form here, but eventually you'll see a pattern of bright and dark, bright and dark. So a strong red reflection. You can see it gets kind of dark there, dark, dark, dark. I'm trying to point at it. And so, and the bubble's wiggling a little bit. You can see that here. So when it wiggles, that's causing trouble. That's just, right? Looks kind of cool. Oops, sorry about that, Angus. So let's go ahead and do this one more time here. And what you'll see is, again, the red reflection off the front and the red reflection off the back will interfere. In this particular case, when it hits the higher index, the water, there's a phase reversal. On the back side, when it goes from water into air, there's no phase reversal. We'll discuss this in a minute. But in this case, you see one wave that's got a phase reversal reflected in the camera, another one that doesn't have it, and as a result, as time goes on, the top of the bubble gets thinner and thinner, and eventually what will happen is this bubble is so thin, it's thinner than a wavelength, and we're right about now. Notice the top, you don't see any reflection, right? We have a black curtain behind here to really emphasize this. Let's do another one. And basically what's happening is when the bubble gets really thin like that at the top, you have a reflection that's not inverted and another reflection that is inverted. And there's almost no difference in the path length because the bubble is so thin, and so you see a strong destructive interference. And then again, we'll start to see these fringes here. This is a bright, this is a bright fringe, and then there's a dark fringe, bright fringe, dark fringe. And now let's try changing the color. Let's go to blue. If you can, Angus. Oh, there's green, I think. And then if we go back and forth between blue and red, oh, let's do another bubble and let's oscillate between blue and red. Angus is a trooper. So we'll wait a second for the fringes to get set up. And wait, I need to hit the autofocus. Hold on. So I'm going to switch from autofocus to manual focus so that, okay, now go ahead and start switching back and forth. And you should see the fringe pattern start jumping a little bit. As we go back and forth, go for it. Notice the locations of the fringes are different for red and blue. You can throw in the green if you want. And switch, just try random colors and we'll see. Good, good. So what we noticed there, let's keep doing that while I yak and then we'll go to white after this. So the idea here is you see a pattern of fringes, but the pattern of the fringes depends on the color of light used. And so you might notice that the blue pattern is the most compressed. Let's go back and forth between blue and red for a minute. So let's let it set up. So go ahead and give me the red. So there's the dark fringe for red. Go ahead and flip it to blue. And we can see it's not exactly in the same spot. So as a result, every different spot on the bubble is reflecting light of a different wavelength. Let's go ahead and go to one more and let's do the white light now. And so now what's happening is we should see this is an LED source that has red, green, and blue lights in it. And over time, you'll start to see different colors appear in the reflection. Give it time. You might see some purples or some greens or some yellows. And the idea is all the different colors are coming from the different thicknesses of the bubble. It looks a little bit cooler in person. I can see lots more colors in person, but you can start to see. And what's happening is because the different colors, right, have different wavelengths, they interfere at different thicknesses, constructively and destructively, which ends up making the wild rainbow pattern that we see on bubbles. And this, we'll go into all the things involved in the math in another video. We'll just let this one go and then I'll stop it after this bubble. So let's just see how it goes. You can do whatever you want with the colors, Angus. You can try magenta if you want, or blue and red if that's easy to find. I don't know if that's easy to find. So now we'll just have red and blue coming out, right? So maybe you could see the red and blue interacting. Oh, that looks cool. It's just a soap bubble.